All right. The mean value theorem. And problems that look like this, again, a common type of problem. Find a value of x that satisfies the mean value theorem on 1 to 7, the interval 1 to 7, for f of x equals x squared minus 7x plus 3. All right. If you're watching this video, you might not remember, but the mean value theorem says if f of x is continuous and differentiable on an interval, then there exists c of, there exists a value c, where c is greater than a but less than b, so effectively saying c is in between a and b, and the derivative of our function at c is equal to this thing, right? Remember, this is your average rate of change. Of f of x on a to b. And remember, a derivative tells you the instantaneous rate of change at a certain point, right? Don't forget Mr. Slaney leaves school at t equals 0, f of t equals t squared. How fast is he moving at 3 seconds, right? Please tell me that you remember that problem. No, you definitely do, because you're a great student. Thank God I'm doing this at school and there's no cats here. So we are effectively trying to find when is the instantaneous rate of change, when we're looking at this problem. Remember, this is YouTube, so you can always pause it if I'm talking too fast, which I definitely am today because I'm in a rush. Find a value of x that satisfies the mean value theorem on 1 to 7 for f of x equals x squared minus 7x plus 3. So there's a few things that we need here. We want the average rate of change. What this question is trying to ask us is find a point between 1 and 7 where the derivative is equal to the average rate of change. Where the derivative is equal to the average rate of change. So that value of x satisfies the mean value theorem. Let's find the average rate of change. So I need, right, a to b, f of b, f of a, 7 and, b and a. F of 7 equals, let's see, 49 minus 49 plus 3 equals 3. F of 1 equals 1 minus 7 plus 3 equals, I can do this, I'm a big boy. Negative 6 plus 3 equals negative 3. 7 is 7, So meow, I want to find the average rate of change. I'm going to do 3 minus negative 3 over 7 minus 1 equals 6 over 6 equals 1. Oh my gosh, I can't believe there's a nice answer to this problem. Or so far. I want to find now the x value. This is my average rate of change. Keep in mind, this should remind you, or at least feel a little bit like this formula here, like the slope formula, because that's what it is, the slope between two random points. So, I have my average rate of change. Don't forget, this is calculus. You're probably going to want to take a derivative. Anyways, just for fun, f prime of x is 2x minus 7. I want to find the value of x, or my instantaneous rate of change, which is f prime of x, is equal to my average rate of change, which I figured out to be 1. So that's just 1 equals 2x minus 7. Plus 7, 8 equals 2x. Divide by 2, 4 equals x. That's all there is to this. Right? I found my average rate of change, and I set that equal to my derivative. My average rate of change is equal to my derivative. The mean value theorem, you probably remember this as, was Mr. Slaney speeding on his way to Boston? If you went 100 miles in an hour, at one point you probably went 100 miles an hour, right? What this says for this f of x, if the slope in between 1 and 7 on average was 1, well, at x equals 4, the instantaneous rate of change of f of x was 1 at x equals 4. Ugh. Again, there is room for deeper thought, but for just getting through the homework that I've assigned to go along with this video, you can carry out this process. Remember, f of 7 minus f of 1 divided by 7 minus 1. Here, my b was 7, my a was 1. I calculated f of 7, I calculated f of 1. 49 from 7 squared, 1 from 1 squared, minus 49 from negative 7 times 7. Took this value, whatever it was going to be, put that equal to my derivative. All right, have fun.